Alrighty. Hi, everybody. This is the walkthrough video for Monday. It is February 3rd in Try 2 Week 11. And this week's yellow bell work, it should say fill out. My goodness. Good thing I'm doing this early. Page 55 is this week's yellow bell work. It is also the last yellow bell work in this class because our class ends next week. Isn't that nice? So you should have learned from your time thinking through assignments what this percentage is. Question for you is, what percentage of a trophic's level's energy passes on to the next level? Now, the matter might be different, but I'm asking a question about energy. If you don't know, I think a quick Google search will take care of it for you. Here's our what for today. We're asking, how can we use our learning to restore biodiversity and healthy ecosystems? Because that's what the end of this course is all about. We've thought about a lot of different types of systems that work in biology, and we're going to take what we've been learning specifically about ecosystems. Photosynthesis and respiration play an important part, as do some of the other things you know that living things do, to be able to get how living things get their energy through food webs and energy pyramids, so that we can, by the end of this week and next week, design our capstone experiment inside the simulation of gizmos. So today, folks who need to, we're going to finish the ecosystem STEM case. I'm going to talk about that for a moment. And then we're going to work through the study guide and vocab for 2.4. This is the quiz for tomorrow is on carbon cycling. That's 2.2 and 2.5, as we'll see in a moment. This one, however, is our next to last topic in the content. So here is our table of contents page. We have two new items in the table of contents for you. They're split. Isn't that interesting? One of them is the week 11 bell work. That's page 55. And then the other one is the study guide. Unusually for us, we are going to be turning in the study guide because it has some practice problems that we think you are going to want to see one more time based on student feedback from last year. So, all right, so where have we been? While I've been gone, you've thought a great deal about this idea that energy, as you move up in an ecosystem from the plants up to the keystone predator, not keystone, the tertiary or highest predators, that you see this change in energy. We have some words for that. No, we know that plants are autotrophs, they make their own food. We know that predators and herbivores are heterotrophs, they have to eat their food. The organisms that break down poop and dead and dying things are also heterotrophs. And we know a little bit about organizing these organisms into a food web. Now, in this case, you make sure you drew the pointy arrows into the shape of the organism that is doing the eating. So, for example, if you are a mushroom feeding on decaying wood from a pine tree, the arrow would go this way and be pointed to the mushroom. And you took a look at taking on this role of being a National Park Service employee to review that information and also to learn about keystone species. If you didn't watch my video from, I think it's Friday, make sure that you have watched that. It doesn't have to be a wolf. I said wolf because I was looking at an ecosystem in which a wolf was a top predator, but in tide pools, it's a starfish. So now our goal for today is to think about finishing the ecosystem STEM case, but I wanted to introduce the study guide for you in this video. I feel like the STEM case is pretty straightforward if you are in that gizmo. If you are not, you are going to need to get into there and then you literally just play what it tells you to play, do what it tells you to do, and there are instructions on the top of this assignment, which I guess I will show you really quickly, that will tell you you're just going to use the online ecosystems handbook when it tells you to be able to solve the problem. It looks like a lot of people got this one right who turned it in. Looks like a lot of people got this part right. And you may need to think more about these questions if I pass that back to you with an incomplete. All right, let's take a look at the study guide because that is the goal for today. If you're on time and working, that's what you should be working on today. So I wanted to share with you that the Yellow River is the second longest river in China. It originates in Western China and it goes through 9 provinces, kind of like our states, before emptying into the Bothai Sea. The yellow color comes from soil eroded in the lower parts of the river. The Yellow River estuary that forms where the river meets the sea is an important and delicate ecosystem. Scientists are concerned that this ecosystem could be damaged by human development along the Yellow River. That means when people build houses and shopping malls and all kinds of things. Therefore, scientists from China and Germany have started monitoring this ecosystem. Researchers measured carbon and nitrogen levels in the seagrass ecosystem along the delta, this area that is kind of swampy land. The Google map shows to the left, indicating where the study happened. 14 living trophic groups from primary producers to fish were studied, and they measured the total biomass, that's the matter in the system. So here's the food web to show you. And then some of the organisms, it just says seagrass. And here's an example of seagrass. Some of them, it's really specific, like Spartina alterniflora looks like this, whereas, Synectogobius hosta looks like this. It's a goby fish. So those are the pictures of the organisms that might be useful for you. And then you're going to identify food chains. Remember how to do that? It means that you write the producer and then you draw an arrow and then you write the primary consumer and then it goes like that. So that's going to be the food chains. And remember, the food web might show you there are only two at the top of the trophic level. One of them is Synectoposis hosta, it's our goby fish, and the Laterolex japonicus. There it is, that fish, right? So all of your food chains here are going to end with that organism. And then, as you can see here and here, we've got a big list of those organisms. I don't know if you can tell this, it should be like one big table. So this information should be underneath. So you're going to get organisms, trophic level, and biomass, not energy, but biomass. And they're going to get organism, trophic level, and biomass. But these are the third, fourth, fifth, and sixth. These are all the first, and these are all in the second trophic level. So I think that will help you as we do the next thing. What percentage of matter flows between trophic levels in this ecosystem? So what you're going to do to figure that out is look at the total amount of biomass. You're going to add up all of the biomass that's in the first trophic level, right? So you're going to add all of that up. And then you're going to figure out what percentage of this total amount moved from here. And that's how you're going to calculate it. It turns out that on average in this ecosystem, if you do it again, like you add all this up and you divide it by the total of the second, you get a similar enough number. So you only need to use the first and the second, add up all the biomass in the first. That is your 100%. So you're going to take your second, divide it by this total amount. I'm pointing like you can see. And then make sure you multiply by 100 because you should be moving from decimals to places. And then how are you going to support your answer? If you didn't do your math here, do that math here. One more time, add it all up for each level, then determine the percent of the next level, right? So in the next level, that level 2 divided by level 1, and make sure you take the sum, add it all up. And then this reasoning part, this is where you're going to write a couple sentences about why that's happening. Why are you getting less mass in the second layer of organisms that are alive from the first? And then you're going to use some of the information you've learned in our class to be able to answer that. Okay, the other thing you need to know is that the amount of energy and matter are not conserved at each trophic level. So what you're going to do is, here is the surrounding area. Here are the Yellow River trophic levels. Your job is to draw solid arrows that show how energy moves in this diagram. And then to show a dotted line to show how matter moves in this diagram. Now, this can be tricky for people, but if you don't try it, it's going to be really hard for you to correct it and think about what you need to change. So please make your lines light as you do this, and then we'll come back tomorrow to help you think about that. Last but not least, as the usual, we have given you the mathematical representations list that you're going to need. And that's why we're doing this actual assignment rather than just letting you work on it, is because doing this type of math and thinking about using these is going to be really important. So if you're done with that, please work on missing and late work for the rest of the period. Oh yeah, and let me help you here. You need to add the sun. And then you need to add the place where energy goes. We think about it as heat, even though my voice might not feel like heat to you. All the sound waves that I'm making that don't hit your ears are like vibrating the air in such a way that it doesn't end up being heat. Here's a cool down for today. All animals and plants lose CO2. How do they lose it? Starts with an R. If you have questions, let me know. Now, before we move on, I wanted to remind you a little bit about the calendar. Number one, we've decided to have school on President's Day to make up the snow day. So that means that we have this week and next week, and then school is reset, and you're going to go into your third trimester. We will be having a final in this class. We'll be providing the information that you need next week, but we are having class on Monday, January's still up. January's still up. On the 17th. There we go. We're going to have school on the 17th. And the other thing I wanted to remind you about, and I'm just going to go ahead and show you this in Canvas. I'm going to get there while I work, is that we are at the last days for missing assignments this week. I had quite a few families write in feeling concerned about student performance. Just a reminder that everything we do is always on Canvas. If you're trying to figure out what an assignment looks like, for example, here's the ecosystem STEM case, here's the website where you log in. And this is also where you're going to be able to find feedback on your grades. So tomorrow we're going to take this quiz on carbon cycling, and then we're going to use what we've learned about carbon cycling and about 2.4 to update your study folder. Looking ahead, we're going to do a quick study guide review on Tuesday, and then we're going to do an assignment together about population growth. When populations of humans or other organisms get bigger, there are some changes that happen. And when they get smaller, there's some changes that happen. And we'll think about that in a new way. On Thursday and Friday, we're going to explore a coral reef. Now, these assignments, you might need a little extra time to finish them outside of class, and I did want you to know that, because on Monday, in addition to doing some review of next week, we're going to be thinking about how to use that information to be able to design an experiment. Excuse me. So what can you do to study in the meantime? You should look over all the previous study guides. We have a lot of them now in this, right? Like we're on page 3 of our table of contents. So you have, starting at Bio 1.1, you've got study guide and vocabs. You've got information about body systems. You have your study folders that you've been making for 1 and 2. We will make 3 together in class during finals week to make sure you've had that experience to review. If you want to start early, you're welcome to pick up a folder at any time and get to work on it. They are hole punched and in the extra pages box in the back, like next to them, I guess. So, all right, that's it for me. I hope you're doing well. If you are absent, I am here in Panther Plus to help you when you get back. And just a reminder, all the late work through Friday of last week is due last call this Friday. And the piles are getting pretty big. So just be advised, if you turn stuff in this week, it is a courtesy week. You might not get feedback on it. So make sure you get it in. So if there is a chance for me to give you that feedback, that I will. All right, that's it for me. I hope you are doing well out there. See you soon. Bye.